I'm going to be telling you how to make your own Ethereum token that you can deploy on the Ethereum blockchain. Before we get started making the actual token, we need to download this program called MetaMask, which will allow us to talk to the blockchain so that we can deploy our token once we have made it. And you can get this from the Chrome Web Store. It's a simple Chrome extension, and I've already downloaded it. So if I go ahead and click on my MetaMask, you can see that I'm connected to the Ethereum mainnet, and I have about 50 bucks of Ether in here from before. Now, every smart contract, including the one that we'll make, will cost real money to deploy on the blockchain, and I don't really want to do that right now. So instead, what I'm going to do is I'm going to go to one of the test networks, let's say the Gurley test network, and I'm going to use this as my test blockchain for my token so that I can, once I make the contract, I can deploy it to the network without having to spend real money. So why can I do that? It's because this is a test network, so I can get free Ether on it. So you see I already have 1.1418 Ether, and if you want any more, it's very easy. All you need to do is find a faucet for the test network that you're working on and just ask for some Ether. So for instance, I'm on the Gurley test network, and if I wanted more Ether for whatever reason, I could just go to a Gurley faucet, for example this one, and I can type in my Ethereum address, which you can find very easily on MetaMask. If you go back here, you can see below account 1, it has your public address. You can copy it to keyboard and you can click it there, and then you can ask it to give you Ether. And then you can populate your account on the test network so that you can actually start talking to the blockchain. So now that we've downloaded MetaMask and we can talk to the Ethereum blockchain, we can get to actually coding up our token. To do that, we're going to use the Solidity programming language, which is the default programming language for all Ethereum smart contracts. And we're going to be working with the Remix editor, which you can access very easily by typing remix.ethereum.org in your web URL bar, your browser URL bar, and you'll hit this page. And so go ahead and click on New File, and let's call our file token.sol, and we open up a new empty file. And so the first thing that we want to do is, since Solidity, like Java or C++, for those of you with programming experience, is a compiled language, we need to tell Solidity what version of the compiler we want to use, what version of the language we want to use. So the way we do that is by simply saying pragma solidity 0.8.6. So I believe that's the latest version, so I'm just going to go ahead, it's the latest version as of when I'm making this video, so I'm just going to go ahead and use that. Now we can actually start thinking about how our coin should be structured, how our token should be structured. And here the Ethereum community kind of has some guidelines that any good token should follow. And this is set out in ERC-20, which I've got open right here. So this is the ERC-20 token standard. So it tells you, what a token can be. It could represent all sorts of things: reputation points, lottery tickets, an ounce of gold, a fiat currency. So for instance, like many of you may have heard of USD Tether, that's technically a token. Tokens can represent a lot of things, but all good tokens will share some fundamental functionality, which is what ERC-20 sets out. And so what it tells us is that there's a few methods that we need to implement, and these are given here. So we can quickly go through them. So one is a function name that basically tells you what the name of your token is. The second function, symbol, tells you what the symbol of your token is. Decimals tells you how many decimal points your token is denominated to. So for instance, if it's denominated to 0 decimal points, then you can only have integer values. Whereas if it's denominated to 1 decimal point, then you could have something like 1.1 or 1.2. Total supply tells you how many total tokens there are in circulation. Balance of takes an address given by owner, and it basically tells you how many tokens owner has. Transfer is a very important one. it allows us to transfer a value number of tokens to the address given by 2. And then transfer from is a slightly different function that allows us to transfer from a third party given by _from to another party given by _2, and we can transfer the value _value. Approve is a function that allows you to approve transfers from somebody's account _spender up to the value _value. And then allowance is a similar function which governs how much money you can take out of owner's account and give to spender so that spender can spend. In addition to these functions, we have these events, and this is not really a video about the basics of Solidity, but essentially the idea behind an event is an event marks something that should be recorded on the blockchain. So for instance, if you transfer money from someone to someone else, you probably want to record that on the blockchain, so that should be saved with an event. And this is exactly why the first event that they have in their standard sort of recommended list of events is the transfer event, which transfers money, which records a transfer originating at _from and going towards _2, and the transfer value is _value. And another event that they have that I won't be concerned with so much about in this tutorial is an event that marks approval when the address _owner and is allowed to spend _value tokens from _spender. Okay, so now we're really ready to start coding up our token. And I'm going to start off by making a link to that ERC-20 token standard that we just saw. The contract that I designed will implement basically everything that the ERC-20 standard wants me to implement. So there's a bunch of ways to do this. The way I'm going to go about it is I'm going to, before making my original contract of my token, I'm going to make an abstract contract, and I'm going to call it ERC-20 token. And now what I'm going to do here is I'm basically going to copy exactly what they want me to put in. Just going to tab everything. So these are all the functions that this ERC-20 token is meant to implement, and I'm also going to copy over the events that I meant to implement. Now what this is an abstract contract, meaning this is basically a blueprint for what an ERC-20 token should look like. This code doesn't get executed, but it just acts as a guideline for any ERC-20 token, and we'll see how this works later. So after I've got that definition of an ERC-20 token, there's another contract that I'm going to implement first as setup, and I'm going to call this contract owned. And what this contract is going to do is basically define what it means for something to be owned, because our tokens are obviously going to be owned by someone. And it's that sounds kind of meta, but it's fairly straightforward. So our contract is going to have two variables. It's going to keep track of its owner, and it's also going to keep track of a potential new owner once the token changes hands. And we're going to mark a change in ownership with an event, and let's call it ownership transferred. And it's going to take an argument of the person that the ownership is going from, and the argument of the person that the ownership is going to. Now the next thing this contract needs is a constructor to be able to actually create an instance of this contract. This is the function that's called whenever we create a contract owned. And all we're going to say is when you start off, your owner is going to be message.sender, where this represents basically whoever is calling the smart contract on the Ethereum blockchain. We're saying that the owner of the token or the owner of the contract is whoever is calling it. Now, we're also going to have a function to be able to transfer ownership. And it's going to take an address that we want to transfer it to. It's going to be a public function. So the first thing is we want to have a condition requiring that the sender of the contract is really the owner. I mean, this might be superfluous in many cases, but it's just a good fail-safe to have. And once you're sure that whoever's transferring this is actually someone who's allowed to transfer it, you can simply say that the new owner is equal to 2. And that's that. Now we're going to have another function. This one's technically not necessary, but it just depends on how you want to design it. And I'm going to call it accept ownership. So basically, whoever ownership is being transferred to has to agree to accept it. Only the new owner can accept. So we have to require that the person who's calling the contract has to be the new owner. So hence this requirement. And once this function is called, what we're going to do is we're going to emit an event of ownership transferred from owner to new owner. And then we're going to formally change the event as the ownership. The owner of this contract is now the new owner, and there is no new owner anymore. So what we're going to do is we're going to set that new owner variable to address 0, which is sort of like the garbage address in Ethereum, where things that don't matter get assigned that address. So we've implemented our owned contract. Now I'm going to implement the actual contract that we all care about, which is the token contract. We're going to start with contract token, and now I'm going to say is ERC-20 token and owned. So what this is saying is that any contract token is also a contract of the type ERC-20 token, and is also a contract of the type owned. So in addition to whatever I may define in this space between these parentheses, I'll also get the functionality that I defined above. Since ERC-20 token is an abstract contract, what this means is that since I'm saying token is an ERC-20 token, I have to actually define how all of these functions should work in this token. You know, if you're familiar with programming, this is basically just like inheritance in many other programming languages. First, let's define all the key parameters of our token. So first is a string. That's basically the symbol of our token. Then we're also going to have another string saying the name of our token. Then we'll specify the number of decimals our token can be denominated in. We'll also have its total possible supply. We'll also designate an address that is allowed to be able to mint new currency. So I'll call it minter. So this is sort of the central authority that'll be able to mint new coins and distribute them or remove them from circulation if you want. And then what I'm going to create is a mapping from addresses to integers, and this is going to be called balances. So this is really going to be the heart of our currency. This mapping is going to sort of be a table where each address gets mapped to how much currency that address owns. And so this is what will really keep track of all the transactions that are going on. Now, as before, we need to make a constructor for our tokens. So let's do the same thing, constructor. And we need to initialize all our variables. So I'm going to say symbol equals, we'll just call it TK for token. Our name is just token, and these are both strings. Decimals, I'm going to say, actually I'll just say 0 for now, keep it simple. And then the total supply, I'll say is 100 coins. And finally, for the minter, I'll just give it my public address for now. So let's copy that over here. So this is the address that all initial currency will be sent to. So what we do is we start off by saying balances underscore minter is equal to total supply. So what this line did is it gave all of my initial supply to this one address, and now that address can distribute it. And you know, you can initialize your currency however you want. I'm just doing sort of the easiest thing. since there was a transfer of currency, what I'm going to do is I'm going to make a record of it in the blockchain through a transfer event. I'm going to say there was a transfer from, address 0, the void, to the minter, and the amount transferred was total supply. Now we're going to implement the functions from the ERC-20 token section that we declared but never actually implemented. I'm going to start off with these first five functions. Let me copy them down here. And now what I'm going to do is I'm just going to change it slightly. I'm going to say now name has a proper definition where we simply return the name of the currency. And what we need to do is we need to make another small change. So you'll see here that after the name of the function, which conveniently here is name, we have these modifiers which tell us information about the function. So public defines its scope, who can see this function. View tells us that this is a function which simply tells us the state of our currency. It doesn't modify any variables. It simply returns a view of the situation. And this last part tells us that this returns a string, and that string is the name. But what we need to do is after public, we need to add this word override just to tell the compiler that now we're overriding the definition of name that was up here. So we're overriding this definition, and now this is the actual definition of name. And it's very similar for the remainder of these methods. So I'm just going to go ahead and do that. So here we've implemented all the view functions in the ERC-20 token interface that basically tell us the full details of our currency. So these tell us the critical details of our currency, and this last function, balance of, basically looks inside the balances mapping and asks how much money does the address owner have associated with it. So now we've defined all those easy view functions, we can define the more juicy functions that remain in the ERC-20 token interface. So let me copy these, and what I'm actually going to do is I'm going to implement the transfer from function first. So what we're going to do is let's remove this keyword, and we're going to say we're overriding now. This function is going to transfer from an address underscore from, and it's going to send to an address underscore to, and the amount of value it's going to send is underscore value. So before we can do that, we need to require that from actually has enough money to send. So we're going to need that the balance for his address is greater than or equal to the value that he's trying to send. And then if that's true, his balance goes down by value, so minus equals value. This is the same as saying balances underscore from equals balances underscore from minus underscore value. It's the same thing as that. And then similarly, we need to increase the balance of the guy who's receiving the money, so plus equals value. And there was a transfer of currency, so we need to emit a transfer event to record this in the blockchain that we sent money from underscore from to underscore to, and the amount was underscore value. And then finally, we're going to return true if the transfer was successful to conform to the token standard. Now, this function transfer that they've defined in the standard, you'll see is actually really similar to transfer from. In fact, it's just a specific case where transfer now transfers from whoever's calling the smart contract on the blockchain to the address that they target, whereas transfer from allows the person who's calling the contract on the blockchain to transfer money from somebody else's address to somebody else's address. So you see that transfer is just a specific instance of transfer from. So we can actually save ourselves some time and have our code look slightly cleaner by simply saying that transfer returns transfer from, and now instead of having a from, we're just going to be message.sender to the address to and the address value. So we've saved ourselves from having to basically copy these lines again in this transfer function. Now these last two functions, approve and allowance, so what approve does is it approves somebody else to spend a value from your account. I don't really want my currency to have this. So what I'm going to do is I'm going to keep these methods to conform to the standard, but I'm just going to return true and it'll do nothing. For your coins, you should obviously, if you want to implement this, you should feel free to go ahead and implement something cool here. And then similarly for allowance, I don't really want third parties being allowed to spend money from other people's wallets. So I'm just going to say return 0. No one's allowed to spend money from other people's wallets. Now I'll add 2 more functions. So the first function is going to be mint, and it's going to take an argument amount, and it's going to return a boolean if the minting was successful. And what it requires is that whoever is initiating this request has to be the minter of the currency. And then if that's true, we can simply say that their balance, the balance of the minter, increases by the amount minted, and the total supply of the currency also increases by the amount minted. And we're going to return a true if everything worked properly. Now you can also implement a more dictatorial version of this called confiscate. So mint will expand the money supply and confiscate can shrink it. And of course for confiscate now you can have a target to steal money from. So you can say address target and you want amount public return bool, so return a boolean once again. And you're gonna have to require that only the minter can do the confiscating. And since I don't want people to have negative balances in my currency, I'm going to say if the balance of the target is greater than or equal to the amount that I'm trying to confiscate from him, then simply reduces balance by that amount, and of course reduce the total supply by that amount also. However, if it's not high enough, then simply what we're going to do first is we're going to simply basically take all he has in his account. So we're going to say total supply minus equals balances of the target. So all his money has been removed, and now we basically empty his account. And then finally return true if your dictatorial plans have worked and you have seized people's money. So now we have a way to inject new currency into the money supply, as well as to remove new currency by force. Now we've got some solid basic functionality for our token, which will allow us to transfer it and mint it, as well as remove tokens from circulation. Now we can go ahead and actually try compiling our smart contract and deploying it to the test blockchain. So to compile, you click this button. Oops, not this button, sorry. You click this button, the Solidity compiler, and you see here that my compiler is 0.8.6, which matches the 0.8.6 up here. And I'm basically going to go ahead and compile. And you see it came up with the 7. There's some warnings here. You can typically ignore those. The best code will obviously not have warnings, but just to get started, you can ignore them. But this is great because now what it means is our contract is ready to go and we can deploy it. So to do that, first, we're going to change the environment from this JavaScript VM to now an injected Web3. And you'll see that these things changed automatically, because what it does is if you go here now, you'll see that MetaMask says it's connected to remix.ethereum.org. Since I've done this process before, my account was automatically connected. What you might need to do is after you've selected Web3, you might need to click MetaMask and then manually initiate a connection if you haven't done it before. But all right, we're connected now, and you'll notice that I'm invoking the contract as this 0xD1 address, which is my address. And what I'm going to say is we're going to deploy the token. Let's go and deploy it. So MetaMask opened. It's asking me for gas fees, but I don't care because this is a test blockchain, so I can spend as much Ethereum as is necessary. And so I go ahead and confirm it, and you can see that my contract deployment is in progress. And now my contract's been deployed. And so it shows up here in MetaMask as well as here in Remix. However, so you can see that I've lost Ethereum since I deployed the contract, but I don't actually have my token show up. So what happened? Well, what we actually need to do is we need to click add token. And now you see that we need the token contract address. So this token contract address refers to the address on the blockchain of the smart contract that we just deployed to create our currency. So we actually, Remix is very nice because it gives us this contract address. We don't have to go searching for it. And it's right here in deployed contract. And you can click this button to copy it to keyboard, and you can go back to MetaMask. So let's go back to add token, and I'm gonna copy it. And you'll see that it automatically populated the token symbol field TK, and it said that our token decimal is 0. So what I'm gonna do is I'm gonna click next, and it says I have 100 TK. There we go. So now look, it shows me with 100 TK. So we've managed to deploy our token onto the Gurley test network. And the process for the Ethereum mainnet would be exactly the same. It's just that you'd have to buy some real Ether to deploy your token. And to see if we can try send it, you can go to MetaMask and you can click send. And here's a friend of mine who I sent some currency to before. So I'm just gonna send him some fake currency now. And let's see, how much should I send him? Let me send him 10 tokens. And you know, these gas prices we don't really care about because we're on the test network, so it's all free. But if you're designing a real blockchain token on the real Ethereum blockchain, gas prices are something that of course you have to keep in mind. But all right, here is our transaction. Let's confirm it. And now we're sending some tokens to our friend. And there we go. We've sent our token. So you see MetaMask tells us we've sent away 10 tokens, exactly as we'd said, to the address that we wanted to send it to. And if you check your assets, you see that I actually do have only 90 tokens now. The final thing we can check now is those other two methods that we created, whereby we can increase the money supply as well as destroy the money supply. So to be able to play with those mint and confiscate methods, we need to go back to Remix, and we go to our deployed contract and we click this arrow, and you see all these functions that we define. And in particular, what we want to do is, suppose, let's say we want to mint 10 coins so that we get our 100 back. So I'm going to put 10 over here and I'm going to click mint. MetaMask opened up again. It's saying you want to do a transaction. Are you willing to pay the gas fees? Yes, I am. We've initiated the transaction. It's pending. And there we go. We've minted some currency. So our transaction is done. And if we see, we're back to 100 tokens. And now suppose I wanted to confiscate my own wealth. What I can do is I can go down to confiscate and I can click the arrow and I can copy my own address in, and I can try take back the ether that I just gave myself. And we're gonna go through the same drill, and my contract's deployed. So now we'll just wait till it runs. And now my contract is finished running, and lo and behold, I am back at 90 tokens. So that was it, guys. Thank you so much for watching, and I hope you had fun learning about how to make your own Ethereum token. The token we implemented was a fairly basic one with the ability to transfer ownership between different people, as well as creating and destroying tokens. But I hope you saw that there's really a lot of scope to go wild and let your imagination run free and really implement a lot of cool stuff. So I hope this video encouraged you to go out there and try this yourself, indulge that central banker within you, and I'll put this file that we wrote up on my GitHub, and I'll leave a link to that in the description so that you can use this as a template to play around in your own Ethereum token adventures. And yeah, thank you so much for watching.